Everybody. I hope you guys are having a good day today. So, this is week 5, and we're getting close to the end. So, congratulations. And in this video, or in this week, we're going to be focusing on angles and the coordinate plane. So, in your case studies, you're going to be focusing on different ways that elementary students develop their understanding of angles. So, two common ways of thinking about angles is that students will think of angles as corners of a two-dimensional shape, but they also call the vertices of a three-dimensional shape corners as well. And so it's helpful to help them distinguish that angles are two-dimensional measurements. And so usually we use them when we're working with two-dimensional shapes. You can technically still have two-dimensional angles on three-dimensional shapes, but it's only going to include one of the surfaces of the three-dimensional shape, and it's not going to include all the surfaces. So an angle is a two-dimensional measurement. And many students will think of them as corners at first, and then later they'll start to develop their understanding of angles as being an amount that you turn. So for example, if I was facing a wall and then I turn to face the wall to my right, that's a 90-degree angle, because if I were to draw a line straight in front of me to my first wall and then turn and draw a line to the second wall, the angle between those two lines would be 90 degrees, and it was a 90-degree turn. So you'll see some examples of that in the case studies, where students will develop their ideas of angles in those two ways. And then for the video projects, some of you guys will be doing video projects on angles, and some of you will be doing them on coordinate plane topics. So I'll give you guys some more tips and suggestions later on in this video about those video projects. But one thing I want to mention is that the topics that you guys do as your video projects are often middle school topics. And the reason why I have you guys do middle school topics, even though this is a elementary math course, is because the middle school concepts are basically advanced versions of what you guys will be teaching at the elementary level. And so if you can understand how to explain the formulas for a middle school calculation, like for example, the volume of a cone that some of you guys found last week, that's going to help you understand volume on a deeper level, which will help you explain the volume of, say, like rectangular prisms to your third graders, or I actually can't remember what grade that is introduced at, but whichever grade it is, when you teach the idea of rectangular prisms, having worked on the volume of a cone will help you teach it in a more conceptual way, because you'll understand where your students are going and what they will be learning about in middle school. And also, if you do a more complex volume concept, like the volume of a cone, that kind of makes you think about volume in a deeper way than just finding the volume of a rectangular prism. So I just wanted to make that little note here about why some of the video projects are covering middle school topics, so that you're not like, why are we doing middle school stuff in an elementary class? And I hope that as you're going through these, you can see the relevance for the way that you're teaching in your elementary classes. So that's a summary of what you'll be doing for the video projects. And then your homework has a lot of coordinate plane stuff on it. So you'll be plotting the points, finding perimeter and area on the coordinate plane, as well as finding the midpoint, distance, and slope between a variety of points. So that's what you'll see on your homework. And then you'll also have one page where you'll practice measuring angles with a protractor. So an angle, I mentioned this a little earlier, is a two-dimensional measurement that measures the rotation between two lines. So the vertex of an angle is where the two lines meet, which is why students will often think of it as a corner. And the rotation between those two lines is the measurement of the angle. So the way that we describe these with numbers is usually with degrees, although in high school they do use radians as well. And the concept is that a full rotation, so if you rotate in a complete circle, that's going to be 360 degrees. And the reason why they chose the number 360 is because in ancient times, they approximated the number of days in a year to be 360. So technically, there's 365 point something, I can't remember the decimal, days in a year. But in ancient times, they just approximated it to be 360 because 360 is a number that has a lot of factors and is easy to split into lots of different segments. So a whole rotation is just defined to be 360 degrees. And so 1 degree is essentially 1/360th of a rotation around the circle. And so what that means is if you do a half rotation, so if you rotate halfway, then that is a 180-degree rotation. And so any straight line, if you put a point at any point on a straight line and you measure the angle between the two line segments that point separates, the angle will always be 180 degrees. And this is one of the principles that you can use if your video project is the vertical angles project. So some of you will be doing like the measurement of vertical angles and explaining why those angles are always equal. And this concept that a straight line will always have an angle measurement of 180 degrees is the key concept that you need in order to prove that theorem for your videos. So that will be helpful for those of you doing the vertical angle video. And going back to the method of measuring angles, let's talk about how to use a protractor. So a protractor is a tool that you can use to measure the two-dimensional rotation between these two lines. So the way that you use a protractor is you put the vertex at the center of the protractor, which is usually always marked, because it's really important that you put the center of the rotation at the center of the tool that you're measuring. And then you line up one of the edges of your angle or one of the lines with the 0 mark on the protractor. And then you look to see what number the other line goes through. And sometimes you might have to make the line longer, depending on how short or long your lines are. And so basically, the way that you measure this is you say, okay, from 0, if I rotate this amount, that puts me at the 40. And notice that there's actually 2 numbers at that mark. So this is the 40 mark, but it's also the 140 mark. And that's because 140 degrees would be this angle right here. And it's just measuring kind of like a different part of it because this angle is a wider angle, but it's still starting at 0 right here and then rotating a certain amount. So on a protractor, it's kind of like you have 2 scales. You have the one where 0 can start over here and then you rotate around and you can see these numbers going up. Or you have this one where you can start at 0 here and rotate this way and those numbers go up from the opposite direction. So that's how you measure angles. And you can also measure angles that are bigger than 180 degrees. But not all protractors are fully circular, so you may have to be a little creative about it. Like, for example, if I had, I don't know, erase some of this stuff. If I had an angle that looks like this, so say it's like that, and I want to measure what this angle is here, one way you can do it is by measuring this angle and subtracting it from 360. Or another way is that you can extend the line and measure what this is and then add the 180 from this. And in either case, you'll get the same answer for the measure of this entire angle here. So that's kind of how you would measure an angle that's bigger than 180 degrees. So on some of your video projects, you guys will be finding the reason why vertical angles are always equal. So vertical angles are defined as angles that are kind of on opposite sides of 2 lines intersecting. And then you guys will be looking at the sums of interior angles of polygons. So you've probably heard in previous geometry classes that if you add up all the angles of any triangle, they add up to 180 degrees, regardless of what the triangle looks like. So even if you have a triangle that looks like this, if you measure the interior angles of the triangle, they'll always add up to 180 degrees. And there's a similar rule for quadrilaterals and pentagons and hexagons, regardless of the shape of the quadrilateral. So like you could measure the angles of a trapezoid like this, or the angles of a dart that looks like this. And if you measure the interior angles, they will all have a similar pattern, just like all of the angles of a triangle add up to 180 degrees. So for those of you with that video project, you'll need to figure out what the pattern is and develop a formula for that. And then explain why that formula always works. So that's just some tips on those two video projects. And then the other half of you will have video projects that are related to the coordinate plane, where you'll be describing why the distance formula works the way it does, or why the midpoint formula works the way that it does. And all of you will be using the distance and midpoint formulas on your homework. So I first want to talk about what the coordinate plane is and some strategies that you can use when introducing this if you end up teaching sixth grade, because the coordinate plane is a concept that's introduced in sixth grade. And so many of you will not end up teaching it, but it's still helpful to understand where it comes from because it's very related to number lines, which are used in the earlier grades quite a bit. So the idea of the coordinate plane is that you have two number lines that are situated perpendicular to each other. So essentially what this means is that you're taking a one-dimensional object like a number line, and you're taking another one-dimensional object, and you're creating a two-dimensional object with those two. So a coordinate plane is a two-dimensional space that extends forever in all directions. So this graph here is only showing part of it, but technically these graph lines extend forever in all directions. And so the coordinate plane is an infinitely big two-dimensional space. And the numbers on the number lines allow us to describe the location in that space with mathematical notation. So for example, this point right here is 3 units to the right and 4 units up from the center of the coordinate plane, which is called the origin. The origin is basically where the two number lines intersect at 0. And so this point right here can be described with the coordinates 3 and 4, because the first coordinate on a coordinate point always describes where the point is at in regards to the horizontal number line, or the x-axis. So since this point is by the 3 on the x number line, that's the reason why this number is a 3. And then because this point is at the 4 on the y number line, we describe it with a 4. And so to find this point, if you were given, like, say, another point with just the numbers, and you were told that you want to graph -1, maybe 5, in that case, you're going to go to -1 on the x-axis, and you're going to go to 5 on the y-axis, and you're going to ask yourself, well, what point is at both of those places on the number lines? And that point is going to be right here, because this point is at 5 on the y number line, and it's at -1 on the x number line. And so that's kind of the idea of how you plot different coordinates. And if you want to find the distance between coordinates, one way you can do it is to find like the vertical distance and the horizontal distance. But that's not the shortest distance between the points, because if you thought about this as like, I don't know, like a street grid or something like that, it would be much faster to walk diagonally if it was an option, like if it was a field, then you could walk diagonally through the field. And so this is defined to be the distance between the 2 points. And some of you guys will be finding the distance formula, which tells you how to find out what number that distance is. And then other people will be finding the midpoint formula, which is essentially how do you find the coordinates of this point right here? So for both of those projects, the Pythagorean theorem is going to be really, really helpful, especially for the distance formula. With the midpoint formula, you can use the Pythagorean theorem to check your reasoning and to show that the midpoint really is in the middle. But especially for the distance formula, you'll want to make sure you use the Pythagorean theorem. But all of you on your homework will be finding the distance and midpoints of a variety of points. So I just want to show you an example of how you would use the distance and midpoint formulas. And those of you who are making videos about it will explain why the formulas work the way they do. But I want to make sure everybody, first of all, knows how to use them. So let's say, for example, I was looking at this point right here, and the coordinates of that point are -2 and 4 because you're at -2 on the horizontal number line and at +4 on the vertical number line. And let's say that I wanted to find the distance between that point and maybe this point right here. So the distance formula will tell me how long this line is. And then the midpoint formula will tell me what point is exactly in the center. So it looks like it's going to be close to about 0 on the x-axis and maybe like 2.5 on the y-axis. But the midpoint formula will tell you exactly what it is. So the way that the midpoint formula works is you take the two x coordinates and you add them together and then divide by 2. So the coordinates of this second point were 2 and 1. And if I add the x coordinates together, I get -2 plus 2 divided by 2. Lots of 2's going on there. But -2 plus 2 is 0. And if I do 0 divided by 2, I just get 0. And so that seems consistent with our estimation that the midpoint would be at 0 on the x-axis. Then for the y-coordinate, again, you just add the two y-coordinates together and divide by 2. So you do 4 plus 1, which is 5. When you divide that by 2, you get 2.5, which is consistent, again, with our approximation that it would be about 2 or 2.5. And so that's how you use the midpoint formula. And then the way that you use the distance formula to find out how far apart the two original points are is instead of adding the x coordinates together, you subtract them. So I would take 4 and subtract 1, and then you're going to square that and add the y coordinates subtracted squared. So I would do my first, oh, sorry, that was actually my y coordinate, not my x coordinate. That was my bad. It should be -2 minus 2 squared, and then 4 minus 1 squared. So those were my y coordinates. And ultimately, it doesn't end up mattering because you add these two together, and you could add them in the opposite order. But for the way that I wrote the distance formula here, this would be the way you'd calculate it. So you basically say, okay, well, -2 minus 2 is -4. If I square -4, a -4 times a -4 is a +16. So this is going to equal 16. And then this part right here, if I do 4 minus 1, that's 3. 3 squared is 9. So I get the square root of 16 plus 9. And 16 plus 9 is 25. And the square root of that is 5. And so that tells me that this distance right here is 5. And that makes sense, and that seems reasonable, because if you were to take a longer distance by traveling just along the vertical and horizontal paths, you would go 1, 2, 3, 4, 5, 6, 7 units to get from this point to this point. But this diagonal distance should be shorter than that because it's kind of like taking a shortcut versus taking the long route along those horizontal and vertical lines. So that's how you use the distance formula and the midpoint formula. And on your homework, you'll be doing both of these things for several different pairs of points. And you'll also be finding the slope between those 2 points. So whenever you're trying to find the slope of 2 points or the slope of a line, um, this is the formula that you use. And the reason for this is because, like, let's say I was looking at this red line. 2 points that are on the line might be, actually, I'll do this in red. I might use this point, and it's like this point right here is easy to find the coordinates of. Because technically, a line is just an infinite number of points that are all arranged in a specific pattern. So if I wanted to find the slope of this line, I just find the slope between 2 points. And the coordinates of the points that I've chosen are 0 and 5 and 2 and 1. So the way that you use the slope formula is you say that the slope is going to be the y coordinate subtracted. So I'll have 5 be my first y coordinate and subtract 1. And then the second part is to put the x coordinates on the bottom and subtract them. And it's important that whichever coordinate you choose as your second point versus your first point, that you keep it consistent. So since I used 5 in this spot, that means I need to use 0 in this spot. So I do 0 minus 2, and that gives me 4 over negative 2. And when you divide 4 divided by negative 2, you get a slope of negative 2, because 4 divided by 2 is 2, and a positive divided by a negative is a negative. And so what this number tells you is it tells you how steep the line is. Because if you were to find the slope of another line, say this one, so I'm going to use this point, and maybe this would be a good point right here. So this is 0, negative 3, and this is negative 4, negative 6. The slope in that case would be negative 3 minus negative 6, and then 0 minus negative 4. And negative 3 minus a negative 6 is the same thing as negative 3 plus 6. So that would be a positive 3. And 0 minus negative 4 is the same thing as 0 plus 4, which is 4. And so the slope in this case would be 3/4. So the smaller the number is, the less steep the line is. Because if you look at this blue line right here, that is a less steep line than this line, which was much steeper and had a slope of negative 2. So a fraction like 3/4 will be less steep than a slope of a number like 2. And then if it's a positive slope, it's going to be an uphill slope. And if it's a negative slope, it will be more downhill. And when I say uphill and downhill, I'm referencing it if you're going from left to right. So like if you followed this line from the left to the right, it would go down, versus on this one, if you go left to right, it would go up. So that's the difference between a positive and negative slope. And the reason why this formula works is because when you do 5 minus 1 here, essentially that 4 that you get is the vertical distance between these 2 points. And then when you do 0 minus 2, you're finding the horizontal distance. And so that's kind of what those parts of the slope formula are telling you. And when you divide those two distances, it will give you a unique ratio of like how much you're going down compared to how, or up, compared to how much you're going left or right. And so the ratio of how much you're going up or down compared to left or right defines how steep something is. Because like if you think about hiking on a mountain, if you have like a big change in elevation without very much vertical or horizontal distance, then that means that the trail is going to be really, really steep. But if you have just a little bit of elevation change for a lot of vertical trail distance, then your trail is not going to be very steep. And so it's the ratio of how much you go up and down compared to how much you go side to side that defines how steep your line is, which is what the slope decides or what the slope describes as a number. Um, and that reasoning of finding the distance between like the vertical distance or the horizontal distance will be really helpful for those of you that are trying to prove the distance formula. So I've given you guys a couple hints on how to create your videos for this week. And if you have any questions, let me know. But I hope that this was helpful.